In this lesson, we're going to learn some compound angle formulas. First, we're going to learn how to derive the formulas, and then we're going to apply them. So, a compound angle formula looks something like this. Cosine of x minus y. Now, please don't say cos of x minus y equals cos x minus cos y, because a lot of students, what they do is they apply the distributive property here, but that's definitely not true. Cos of x minus y is actually equal to cos x times cos y plus sine x times sine y. Okay, this is called the compound angle formula, because if you look at the angle here, it's x minus y. It's a manipulation of two angles. In this case, we're finding the difference of the two angles. So that's why they're called compound angles. We're going to learn 6 of them. This one is called the subtraction formula for cosine. Now, where did the subtraction formula for cosine come from? So what we're going to do is we're going to study the unit circle and see how we came about this formula. So what we have here is a unit circle. We have an angle of x and an angle of y. Now if we rotate y radians, then here you're going to get cos y sine y. This point on the unit circle is defined as cos y sine y. Now if you rotate x radians, then you're going to get cos x sine x at this point of the unit circle. Now what we're going to do is we're going to join these 2 points of the unit circle. So that's defined by the line segment C. Now we can find the length of this line segment 2 ways. We could use the cosine law, or we can use the length of a line segment formula, both of which we learned in grade 10. So if we use the cosine law, we can do that because we have 2 sides and a contained angle. So the 2 sides are actually the radii of the circle, of the unit circle. But what's the contained angle here? It's not x, it's not y. This angle here is x minus y. Okay, so the contained angle is x minus y. So if you go down, this is what we have here, the cosine law. C squared equals a squared plus b squared minus 2ab cos c. So we sub in a and b as 1 because that's the radius of the circle. And then c squared, the length of the line segment squared, is equal to 2 minus 2 cos of x minus y. Okay, so remember it's x minus y because that's the size of our contained angle. Now that was a cosine law, but I said that we can also find the length of C using the length formula. Okay, so if you remember, the length formula is basically the Pythagorean theorem, the rise squared plus the run squared. So we have y and x here. So the y coordinates of the 2 points are sine y and sine x, and the x coordinates of the 2 points are cos y and cos x. So anyways, you do a bit of expansion and you get c squared equals all of this. Okay, so we have c squared equals this from the cosine law, and we also have c squared equals this from the length of a line segment. We set them equal to each other, and what is the goal? Your goal is to isolate cos of x minus y. Your goal is to isolate cos of x minus y. And you do some basic algebra, you isolate it, and you get what we have earlier. Cos of x minus y, the subtraction formula for cosine, is equal to cos x cos y plus sine x sine y. Alright, so from the subtraction formula for cosine, you can actually generate the addition formula for cosine. So all you have to do is replace minus y with plus y. Right? Now how do you do that? So you let y equal negative y, because if you subtract by negative y, you end up with adding by y. Okay, so one more time, cos of x minus negative y is equal to cos of x plus y. So that's why here instead of y, we replace it with negative y. Now, how come cos of negative y is equal to cos y? How come cos of negative y is equal to cos y? Let me try to refresh your memory by drawing the graph of cos y, or cos x, or just a cosine graph in general. Okay, it's not the prettiest cosine function, but it gets the point across, hopefully. What do we notice about the cosine function? The graph of the cosine function is special. We talked about this in the first unit of this course. It's special because it's symmetrical about the y-axis. If the cosine function is symmetrical about the y-axis, then we can say that the cosine function is an even function. That's why cos of negative y equals cos of y, right? That's because cosine is an even function. Now, cosine is an even function, but sine, I didn't say sine is an even function. Let's see what sine is. So once again, we'll try to graph what sine is, or hopefully remember from last year. Okay, the sine function is most definitely not an even function. In fact, the sine function is an odd function. So since it is an odd function, sine of negative y equals negative sine y. Okay, so that's how we get the addition formula for cosine. Okay, so cos of negative y, cos is even, so you have cos y. Sine of negative y becomes negative sine y because sine is an odd function. The good news is that the addition and subtraction formula for cosine, they're pretty much the same, except for the fact that one is addition of the two terms and one is subtraction of the two terms. Okay, so we have the addition and subtraction formula for cosine, but now we need to generate the addition and subtraction formula for sine. Okay, so we can actually generate the addition formula for sine using the co-function identity to help us out. Okay, let's see. Hopefully remember sine is equals cos of pi over 2 minus x. This makes sense because pi over 2 minus x and x are complementary angles. So we're going to take sine of x plus y. We know that based on the co-function identity, this must be equal to cos of pi over 2 minus all of x plus y. Now we actually want to rearrange these terms here. We actually want to group pi over 2 minus x together. And you might be wondering why we want to do that. Okay, why do we want to make this transition? Why do we want to regroup the three terms? Because if you think about the subtraction formula for cosine, you're going to get cos of pi over 2 minus x, which you can simplify using the co-function identity. So that's why we chose to regroup these three terms. Alright, so if you follow along, you'll notice that the addition formula for sine ends up being, and that's based on the subtraction formula for cosine, it ends up being sine x cos y plus cos x sine y. And just like how we derived the addition formula for cosine, we could pretty much do the same thing to generate the subtraction formula for sine. So sine of x minus y, you just replace y with negative y. So once again, cosine is an even function. So let y equal negative y. Cosine is an even function and sine is an odd function. And there you go. That's the subtraction formula for sine. So the addition formula for tan, you can think of tan as sine over cos. So using the addition formula for sine and for cos, you should be able to generate the addition formula for tan. So that's what we did here. The numerator is based on the addition formula for sine, and the denominator is from the addition formula for cosine. Now, the next thing we're going to do is not very might not be very intuitive, but you actually want to divide the numerator and denominator by cos x cos y, because if you do it, you'll realize that you have the addition formula for tan. Tan of x plus tan x plus tan y all over 1 minus tan x tan y. So the subtraction formula can be generated pretty quickly using the same strategy as before. Let y equal negative y. Now what we didn't mention is we know that cosine is even, sine is odd, but what about tan? Well, let's see. Tan of negative theta. Okay, that's not very pretty. Let's try again. Tan of negative theta. Okay. Is equal to sine of negative theta over cos of negative theta. And we said sine is odd and cosine is even. So if we simplify that, that's equal to negative tan theta. So tan of negative theta equals negative tan theta. So we can conclude that tan is an odd function. In fact, if you take an odd function and divide it by an even function, you're always going to get an odd function. Anyways, all we wanted to find out was that tan is an odd function. And that's how we can get the subtraction formula for tangent. Okay, so we have the 6 formulas. So addition, subtraction formula for cosine, sine, and tangent. Unfortunately, you'll have to memorize them because we're not going to give them to you on the test. Okay. So if you remember the cosine addition formula for cosine, you can expand cos of 4m plus 5n. So you should end up with cos of 4m, cos of 5n, minus sine of 4m, sine of 5n. Okay? So instead of x and y, you have 4m and 5n. But really, you're just copying the formula here. Sine of 3x minus 4y. So this one, you're going to use the subtraction formula for sine. So sine of 3x cos of 4y minus sine of 4y cos of 3x. Okay, so all you have to do is remember your formulas for these two questions. Now here we're going to go backwards. We're going to try to write each of the following as a single trigonometric function. So sine 4t cos 2t minus cos 4t sine 2t. So which formula should we use to help us express it as a single trig function? It's the subtraction formula for sine. Okay, so it's sine of 4t minus 2t. Because the way it's presented to us, you should use the subtraction formula for sine. Okay, if you have a hard time seeing it, rewrite this expression by letting 4t equal to x and 2t equal to y, and you'll see that it looks exactly like the subtraction formula for sine. Okay, we have cos 7x cos 2x plus sine 7x sine 2x. Once again, if you have a hard time thinking about which formula to use, let 7x be y and let 2x be z. And then you'll see that it looks exactly like the subtraction formula for cosine. So this should be equal to cos of 7x minus 2x, which is equal to cos of 5x. Okay, tan of 7 pi over 12. Tan of 7 pi over 12. How can we figure out tan of 7 pi over 12? What we're going to do, because 12 is not one of our friends. We have 3, 4, and 6. Those are the special angles. But what about 12? Well, now that we know the compound angle, we can break this angle apart to help us find the special angle. the question is, how do you break apart 7 pi over 12? So I'll show you some ways to break apart 7 pi over 12, which are not a very good idea. So for example, I can break apart 7 pi over 12 to 5 pi over 12 plus 2 pi over 12. This is not a good idea, okay? Because 5 pi over 12, I can't find the exact value. That's not an angle that's gonna let me find the exact value very quickly, actually. I can do it, but it's not very quick. There's a much better way. I'll show you another bad way of breaking apart 7 pi over 12. Another bad way would be pi over 12 plus 6 pi over 12. That's another bad way of breaking apart 7 pi over 12. So what's a good way? So those are two ways of expressing 7 pi over 12 as a sum of two angles. A good way would be 3 pi over 12 plus 4 pi over 12. Is that a good way? I think so, because what's 3 pi over 12? Pi over 4. And what's 4 pi over 12? Pi over 3. Pi over 4 pi over 3? Beautiful. So all I need to know now is the addition formula for tan. So that is tan of pi over 4 plus tan of pi over 3 all over 1 minus tan pi over 4 tan pi over 3. And now you just need to remember what tan pi over 4 and tan pi over 3 is. So it's 1 plus root 3 over 1 minus 1 root 3, which is 1 plus root 3 minus 1 root 3. So from here, you should really rationalize the denominator. So it may give us a few more steps, but we're going to do it. So multiply by the conjugate of the denominator. So you get 1 plus 2 root 3, because it's a perfect square trinomial. Difference of squares. So it's going to be 2 root 3 plus 4 all over negative 2, which is negative root 3 minus 2. So, of course, you can use your calculator and check, is tan 7 pi over 12 really negative root 3 minus 2? And you know what? Let's check. So make sure it's in radian mode. Tan of 7 pi over 12. Okay, and negative root 3 minus 2. Perfect. Okay, this question here is pretty much the same as example 3. But I'm actually going to do one step first before I break apart pi over 12. Because I'm actually not working with pi over 12. I'm working with negative pi over 12. And I really don't want to work with that. Luckily, I know that cosine is an even function. So I will never work with an angle that is negative if I'm working with a cosine function. So my first step is rewriting it as cosine of pi over 12. So now I have to break apart pi over 12. So this time I'm going to express pi over 12 as a difference of two special angles as opposed to a sum when I was working with 7 pi over 12. So cos of pi over 3 minus pi over 4. Right? Because this would give me 4 pi over 12 and this would give me 3 pi over 12 and the difference would be 1 pi over 12. So that was the hardest part of the question, to be honest with you, because the next part is just memorizing the formula, and following that would be knowing our special angles. So you need to know the subtraction formula for cosine. Oops, that should be sine of pi over 4. Sine of pi over 4. Okay, so that's the formula part. And now this is the special angles. So cos of pi over 3 is 1/2 root 2 over 2. Sine of pi over 3 is root 3 over 2. And sine pi over 4 is root 2 over 2. Simplify. And you get root 2 plus root 6 all over 4. Once again, you can check with your calculator, but you can do that by yourself. Okay. One side note, I'm going to change pi over 12 into degrees just to help you visualize this question. But pi over 12 is 15 degrees. So you could write cos of negative 15 degrees, but I'm just going to leave as cosine of 15 degrees. This is showing you how beautiful the compound angle is. It allows us to find exact values of cosine 15 degrees, or like sine of 15 degrees. You would never have imagined that prior to this lesson. If I gave you cosine of 15 degrees in grade 11, you'd be like, that's impossible. I can't possibly find the exact value of cosine 15 degrees. Well, it's only impossible if you didn't know the compound angle formulas. But now that you learn the compound angles, you're able to find exact values of many, many more angles. Not just angles that have a reference angle of 30, 45, and 60. You can find the exact values of angles which have reference angles of 15 degrees or even 75 degrees. Okay, just a nice little interesting fact with because some students don't value the compound angles, but it's really powerful. It lets us do a lot of things. Okay, so how else can we use compound angles? Let's look at this question. I'm told tan A is 3 over 2, and A is in the first quadrant. I'm given cosine B is equal to negative 3 over 5, and B is in the third quadrant. To determine the exact value of sine of A plus B. To be honest with you, this is really a grade 11 question with a small dose of grade 12. So really the first step is the only grade 12 part to this question. All you have to know is what sine of A plus B is. So sine of A plus B is equal to, well, you just need to know your addition formula for sine. Sine A cos B plus sine B cos A. Well, if I knew what these four ratios were, then I'm done. Unfortunately, I only know one of the four. Well, that's not that bad. So, 4 ratios and then simplify. So of these 4, I have cos B, negative 3 over 5. I don't know what sine A is. I don't know what sine B is. I don't know what cos A is. But the good news is that even though I'm not given sine A, cosine B, and cos A, I have sufficient information to find out what those ratios are. I'm told tan A. That's what I learned in grade 11. If you tell me what tan A is, I can figure out the ratios for the other 5 trig functions. If I'm told cos B, I can also find the exact value of the other 5 trig functions if the angle were to be B. So I'm going to work with angle A first, okay? Because I have to work with both angle A and angle B here. So angle A, I'm given y is equal to 3 and x is equal to 2, sorry. So I'm going to put some extra notation here because I don't want you to get confused because I'm working with angle A. So x is 2 and y sub A is 3. So that's 4 and 9, that's 13. So we're going to reject the negative root 13. Not because it's negative, because the radius has to be positive. Okay, the radius of the circle has to be positive. Okay, so this one we're working with angle B. That's why we have B. Yes, this B is for our subscript. Y sub B, X sub B, and R sub B. Okay, so this is showing me I'm working with angle A, and this is showing me I'm working with angle B. Now for angle B, I really didn't have to do this calculation. I'm going to do it nonetheless, but I'll tell you why I didn't need to do it. So I'm giving cos B is equal to -3/5. That means, and remember, cos is x over r, so -3/5. I'm going to jump straight to ±4. And that's why I said I really didn't need to do all this math, because when I saw 3/5 as my ratio, or -3/5, right away I saw that this was going to be my 3, 4, 5 triangle. It's one of the most special right triangles you're going to work with. But with practice, you'll be able to recognize these special right triangles. But this is when they work out perfectly. These are called Pythagorean triples, when all three sides of your right triangle are whole numbers. Anyways, should I reject the +4 or the -4? Please don't just say -4. There's got to be a reason. But in this case, we actually reject the +4. Because angle B is in quadrant 3. Okay, angle B is in quadrant 3, so the y value must be negative, right? If you reach the third quadrant, you go to the left and then go down. So we're looking at -4. All right, all this said, let's do it. So sine A is equal to 3 over root 13. And B here, sine B is going to be -4/5. And cos A is going to be 2 over root 13. So it's -9, -8. So it's -17, 5 root 13. You know, I'm not going to skip my step. I'll just, this is -9. -9 minus 8. And that's how I got -17. Rationalize the denominator. There we go. So example 6 is very similar to what we just did, but we're given cosecant of A minus B. So the trick is don't make up any identities, okay? So cosecant is a reciprocal of sine. And then use the subtraction formula for sine. So sine of A cos of B minus sine of B cos of A. So A and B are acute angles. That's really nice. That means A and B are both in the first quadrant. So secant A, since secant A equals 5 over 3, therefore we can say cos A is equal to 3 over 5. And I'm also going to jump to sine A is equal to 4 over 5. How did I know that? I didn't do any Pythagorean theorem calculation like I did in example 5. How did I know sine A was 4 over 5? Because I know of the Pythagorean triple 3, 4, 5. So if I see cos A is 3 over 5, sine A must be 4 over 5. Okay. So tan B is equal to 12 over 5. So what is cos B and sine B? because I need those ratios to answer the question here. Well, I need to know this other Pythagorean triple. Now, if you don't know the Pythagorean triple, you have to do the work like I did earlier. Okay, so you could do the Pythagorean theorem down here, but I'm going to try to save us some time. What's the Pythagorean triple? 5, 12, and 13. So if that's the case, this would be 5 over 13. This would be 12 over 13. So on your own time, maybe you should use the Pythagorean theorem and check that 13 is the hypotenuse of, or the radius of angle B, radius of the circle. All right, but if you do know the Pythagorean triples, you can just write the ratios down. I don't expect you to do the calculation. All right. So sine A is 4 over 5. Cos B is 5 over 13. Sine B is 12 over 13. And cos A is 3 over 5. Okay, so that's 20, and then that is negative 36. That's negative 16 over 65, which will be negative 65 over 16. I do have one question I want to go over. It's basically like example 4, but it's the angle's a lot bigger. So I'm gonna let's do cosine. Why not? I'm gonna do a very big angle. Let's see. Let's do 23 pi over 12. So the reason why I put 23 pi over 12 is because a lot of students have a hard time breaking apart the angle. Okay, so with 23 pi over 12, I'm going to do this question one of two ways. You could choose to just work with 23 pi over 12, or you can choose to work with an angle that is in quadrant 1. So that would mean you need to use your knowledge of equivalent trig expressions we learned earlier to simplify the question. It doesn't matter, both ways works. So to me, the hardest part for if you don't choose to use equivalent trig expressions is to break up this angle. So 23 pi over 12. 23 pi over 12, if you want to break it apart, you got to be very careful. There's a lot of good ways to do it, but let's see. 15 and 8. Yep, 15 and 8 would be a great idea. Because 15 pi over 12 reduces to 5 pi over 4. And 8 pi over 12 reduces to 2 pi over 3. And I can find exact values using those two angles. So addition formula for cosine, just have that memorized. If you derive the formulas, it will help you in terms of memorizing them. Okay, cos of 5 pi over 4. Be careful. 5 pi over 4 is in the third quadrant. 2 pi over 3 is in the second quadrant. So yeah, you have to watch the signs. They're not all positive. So 5 pi over 4 is negative root 2 over 2 because we're in the third quadrant. 2 pi over 3 is negative 1/2. 5 pi over 4, negative root 2 over 2 because we're in the third quadrant. 2 pi over 3 will be positive root 3 over 2 because sine is positive in the second quadrant. Okay, so if you do the math, you get root 2 plus root 6 all over 4. Okay, so this is one way of doing this question without using equivalent trig expressions. But I would personally recommend you to use equivalent trig expressions to help you out. I mean, why not use something you learned? So the first step is not to break apart 23 pi over 12 into convenient angles. I would actually shift it into the first quadrant. 23 pi over 12. What's the reference angle of 23 pi over 12? So 23 pi over 12 is in the fourth quadrant, so you can take 2 pi and subtract it by 23 pi over 12. And if you do that, you'll just get pi over 12. Much smaller angle, and breaking it apart is significantly easier. And what's the good news when you break apart a quadrant 1 angle? The two angles here will be quadrant 1. So you see here, you have to think, you have to pause for a moment. Is it positive, is it negative? Well, over here, I haven't done the step yet, but there's much less thinking involved. I'm just going to say positive, 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 because they're all in quadrant 1. Everything's positive in quadrant 1. So cos of pi over 3 is half, root 2 over 2. This is going to be root 3 over 2, root 2 over 2. So guess what? Exactly the same answer. So I would personally recommend you use equivalent trig expressions to make our lives a little easier, but what I did to begin with is fine as well. Both ways will lead you to the correct answer. Okay, so that's compound angles. So the next part is going to be a continuation of compound angles, some special scenarios basically.